Okay, hopefully I'm back on the speakers. Great. Okay, so I'm going to try and wrap this up reasonably quickly because I don't want to eat too much into Bob's time. But so what I'll do is I'll show you the sort of answers I got. We probably don't have too much time to explain why my answers might be different from your answers, but what people are welcome to do, though, is they're welcome to chat in the Slack, and actually, when Bob's doing his session, I can actually start answering questions in the Slack. So if people have questions for me, or if they just didn't understand the exercise, or things just didn't make sense, then I can be a bit more active when I'm not actually on stage, and so I can probably help out a little bit more there. So just to explain a little bit here, so this is the sort of like the conceptual diagram I started thinking about with the vegetation survey. So there was a lot of different classes here. So one of this is like the occurrence class. So we know, for example, from this vegetation survey data that we have some occurrences from species. Now, I have more rows than the table, and so this is something you'll find quite often in community ecologists. The community ecologists like to have transect often and then column for each species. And you very rarely see data managers handle data that way because they prefer to have like things in like row major format. So you have one row for each like record of every single species. And so this is probably like a conceptual difference you see between community ecologists and sort of database managers quite often. But basically here, what I've done is I've just sort of taken that table and then I've taken it row by row and just split it out into lots of different observations. So in that table, you had 2 transects, and each of those transects had a percent cover for each species, for 3 species. So actually, we actually had 6 occurrences there of that species. And these were these occurrences. But they have a number attached to them, and that was the percent cover. So we have an organism quantity, which was the percent cover, and then a term that sort of describes what that means. So it's percent cover type. And again, we had 3 species in there, so we had a taxon class. There's a reason why I've duplicated this table like this, and I'll explain that a little bit later, but actually you didn't necessarily need to do it. The exercise was more just to see whether you could map these terms appropriately. Just like with the first one, so I got asked actually, one thing I do want to quickly bring up is people ask me like, if I do it wrong, so what I've done here is I have not adhered to Darwin core good practice here, because according to the website, if I look this term up on Darwin core specification, it shows an example of this use, and the example it shows of use is to include the authority in there, and I haven't. So I'm not adhered to good practice. And then people have asked me, well, am I wrong then? Have I done it wrong? Am I bad? And the thing is with the Darwin core is that the standard itself doesn't except in very limited cases, it actually doesn't enforce the contents of it. This could be nonsense. I have still adhered to the Darwin core standard. However, when I then try to deposit my data on a biodiversity database, quite often they have a consistency check, and they'll check to see whether the data here makes sense. So if I just change these into nonsense things like flobbity-floop or something, like GBIF will probably go, and I try to load it on GBIF will like look at these and go, well, this isn't anything I understand, and will return errors. But that's not enforced by the standard. That's actually usually enforced by whoever you want to try and put your data or have your data indexed by more accurately. So what I've done here is I'd be tutted at by lots of people with the standard. They're like, that's not what we said was good practice, but I haven't done anything wrong. I'm not going to Darwin core jail. And again, the same with the event cost here. We have some events. There's a reason why I've duplicated this, which I won't go into too much now because we don't really have time. But again, you don't necessarily have to have exact rows. It's just an idea that we have some events, and this time our event is a transect. And so we can give it a unique ID code. Again, 1 and 2 is terrible ID codes again. I'd be tutted at by Darwin core people, but not go to Darwin core police. But what I might want to do is retain my own internal coding that I used in my field work. And again, I have some information about the location. I've used locality for this, but actually there's a few things that could work. And we knew, and because I'm trying to be totally lossless to incorporate all the data I've given you in that little data snippet, I also want to maintain that it's in Norway, so we have that as well. And then the measurement we took some temperature measurements as well. And again, I've repeated this out, but I won't go into that now because we don't have time and I don't want to steal too much of Bob's time. And I won't go into the camera trapping slides either, because the camera trapping exercise was supposed to be a bit more contentious. That's a bit more of a complicated data set, so that was deliberately to make you argue with each other, so it's just a shame we haven't got that far. But maybe if you just want to argue amongst yourselves in your own time, then you're welcome to look through that data and try and classify that. But I do want to say a little bit about Darwin Core archives. And like I said earlier, we have to be very careful about the Darwin Core standard is one thing. That's your vocabulary, your dictionary you're using to describe your data. And then there's the Darwin Core archive. And that's a particular sort of data transfer format. And they're sort of linked because one of the things is you want to, when you create a Darwin Core archive, you're doing so because you want to make sure your data adhere to the Darwin Core standards. But at the same time, they're not the same thing. So you can share your data in a way that meets Darwin Core standards, or you can describe your data in a way that makes Darwin Core standard, but not use a Darwin Core archive. There are other ways you can describe your data. In fact, actually, again, the Darwin Core standard has some examples of ways you can do data dissemination of your data in a way that's consistently described using the Darwin Core terms, but not using a Darwin Core archive. But there's one particular data type, the Darwin Core archive data type, and the reason why I want to talk about it is because some of the big biodiversity databases tend to use it as the default sort of data sharing mechanism for import. So quite often one of the things is, some of you may have used the IPT on GBIF as a publishing tool to publish your data sets. As part of the process, what it's doing is constructing a Darwin Core archive object and then validating it to make sure that it makes sense for GBIF before then registering it. And so for some types of things, it's a thing you will often need to know about to get your data into some repositories or to get them indexed by some repositories. So I just want to talk a little bit about it, but again, we don't sadly have a lot of time. But like I say, it's just a file format used to facilitate data archival and publishing in biodiversity databases. It helps to ensure your Darwin Core standards are maintained. But data that are not formatted as Darwin Core archives can still be Darwin Core compliant. Like I said, there are ways to share your data in a way that isn't through a Darwin Core archive, but still adhere to Darwin Core standards. The way they tend to work, they tend to use this thing called a star scheme, which I won't go into too much, but you tend to choose one of your class types as being the core type, and that's your core data type. So you decide which of your things is like the core data type you have. And then what you do is you then say, that's my core type, and then the other tables that we created as part of that process, we sort of describe them as extensions to that. So that there's like supplementary data to that. And the reason why I call it star schema is because you sort of sit the core in the center of this scheme, and then there are other things around it that describe the data, that core type in a bit more detail. I won't again say we don't sadly have time to go into too much detail about it. But one of the reasons that Darwin Core archives are quite useful is that I think one of the things is it helps us avoid something that I started calling the master-student event. I think that's maybe a bit unfair. I should have called it the master-student supervisor effect rather than the master-student effect. I think the thing is that we want open data, and typically, though, larger projects that are collecting larger amounts of data, they actually tend to have better data management plans because actually they're already investing in doing a huge data collection. So it's actually, as a proportion of the time collecting data, actually having a good data management plan isn't too onerous. But actually, the worst is usually for projects that are quite small in scale, where you've done quite a lot of effort and where you've done quite a lot of you've got a little bit of effort to collect data, but actually if you're going to try and like archive and prepare that in a way that makes all of these data standards that we've been talking about over the last few days feasible, it basically means that actually as a proportion of the project, a lot of your time is spent on this data management aspect of it. And there often just isn't time available to realistically do that for certain projects. And I call it the master student effect because I feel like the master student thesis is the perfect example of a timescale that sort of is a bit problematic in that you don't have time to get your master's student up to speed, to go out to get them trained to do the data collection, to come out, process the data, analyze the data and get their thesis done. And then if you're also asking them to invest large amounts of time in data management, it really puts a strain on the project. And the result of that is actually so many master's student thesis data just disappear. And so I'm going to bring up Vigdis here, because at the last Living Norway meeting and this morning, Vigdis sort of showed you her list of master's students. And I remember when Vigdis first presented the meeting, that she presented that meeting and showed she had master's students whose data had gone missing entirely was in red. And then data whose students might have gone missing in yellow, and data whose data she knew exactly where they were in green. And I remember looking at that going, I think this has got about a 75% loss rate. And I remember thinking, that's not very good. That's terrible, actually. I'm sure I could beat, I'm sure mine's not as bad. So I worked up my number. So I've had 12 master's students, and I've managed to successfully archive 2 of them. So actually, I have a 1 in 6 chance. So actually, I've lost 82% of my data, whereas Vigdis only lost 75% of data. So I'm actually 77% worse than Vigdis at keep retaining my master's students' data. And I think, so the reason why I talked a bit more about Darwin archive format is because actually one of the things that Matt and I are working on, we got a little flavour of it on Matt's talk, is we've been creating these small-scale R packages to help you sort of take your data frames that probably, hopefully your master students now are getting more comfortable with using. I think R now is sort of a fairly general tool that master students are more comfortable with. And they're used to data frames and those types of things. And we can take those data frames and then package them up as Darwin archive format files. And we're trying to make that process as painless as possible. As I say, it's still in development, so we've definitely got some time to go before we're there. But the hope is that actually that particular package is to try and solve the master student problem, that actually we can package up these very small data sets that we'll collect into Darwin archive, Darwin Core archive format archive, and then the idea that then we can piece together all these small data sets that hopefully then we can sort of get something bigger out of it eventually, so that we don't end up losing 75% to 82% of your master's students' work each time. And I'm actually not sure that I mean, it's very embarrassing for me, being someone who's working on Living in Norway, making a package to try and make things, and yet I've managed to lose 82% of my students' data. So I think, so I'm hoping to improve this number, and hopefully that this package that Matt and I are making will help it. But I think, so I think probably more fairly I should call it the master's student supervisor effect, because it's largely my fault than theirs. It makes it sound a little bit like it's their fault. But I think it's for those projects that we've been thinking a little bit more about, because actually for very large projects, usually the data management is a bit more baked into it, that's been a bit more thought about. I think I'll leave it there for now because I've already eaten into Bob's time a bit too much. But if people have general comments, questions, or questions about the exercises, I'm going to hop onto the Slack now, and so hopefully I can sort of give you some good answers, either if you're virtual or physical. Okay, thank you very much for your time.